Welcome. Thanks for joining us to review what's new and what's next with infrastructure for AI and ML. I'm Chelsie Czop, Product Manager for Compute Engine within Google Cloud, and I'm joined today by Omkar Pathak, Product Manager for Cloud TPUs within Google. First, we'll review our Accelerator mission, AI and ML within Google, how we're able to provide you with a differentiated compute platform, and the ways to take advantage of our accelerator hardware. Then we'll focus on our accelerator hardware platform, cloud GPUs, and cloud TPUs. We'll cover what's new and what's next in the portfolio, and sprinkle in ways that our customers are creating innovative products and services within Google Cloud. At Google Cloud, we believe that cutting-edge machine learning infrastructure should excel at performance, scalability, and usability to allow you to be able to create innovative and differentiated services for your users, all at a low total cost of ownership. Our leadership in AI through both Google Research, DeepMind, and also in the practical applications of AI within our Google products allow us to be able to provide you with an innovative platform for your AI and ML use cases. We bring our experience of deploying AI and ML models in production across all of Google and provide you with the same infrastructure and tools that we use. This means we have accelerators for any of your use cases, from high-performance training to serving models cost-effectively. You're able to achieve the optimal price per performance for your use case through our selection of cloud GPUs, cloud TPUs, as well as compute-optimized VMs on Compute Engine. This gives you the ability to choose the latest and greatest infrastructure to fit your use case needs. Last, and arguably most important for you, is that it's easy to get started and to scale using a wide range of tools and services offered through Compute Engine and Vertex AI platform, allowing you to create business value faster. It really helps to partner with companies that have fully deployed AI and ML in their own production environments to help you overcome roadblocks faster. We have a long history of hardware development, and we're always dedicated to being an open cloud, allowing you a diversity of options from frameworks to application portability. We're at a really exciting time in the world for AI and ML. Every industry will soon be transformed. The organizations that embrace AI and ML in this transformation will have a competitive advantage. To unlock the full value of AI and ML, we must first focus on your business challenges. We're able to do that in two progressive ways. First, you can focus on common business challenges. Shown here are the common business challenges by industry, along with the solutions that we've created to help you easily get started. Then moving on, you're able to solve challenges that are unique to your business. The following solutions, services, APIs, and models all help with AI needs at every single level of expertise and readiness. You really don't need to be an ML expert to get started. We have easy-to-use APIs or AutoML models that allow you to create a customized solution to your unique business challenges. You can plug and play the APIs and models to create exactly what you need. Underneath this entire portfolio are our hardware accelerators, cloud TPUs, cloud GPUs, and Compute Engine. There's three main ways to take advantage of accelerators on Google Cloud. First, via Vertex AI, offering end-to-end AI and ML tooling and scheduling. Via GKE, using containers, enabling GPUs and TPUs as a service, removing the burden from you to manage the hardware of the VMs for your AI workload. Simply give your containers access to GPUs via the Kubernetes API, and then you're able to take advantage of auto-scaling, see the GPU utilization, and scale these workloads up and down based on the demand. Last, also via Compute Engine, we offer custom VM shapes, tooling, and workflow support for you to be able to scale from a single GPU under your desk to supercomputer computing scale available on demand with preemptible instances as well as committed use discounts based on reservations to get you the best price. Our virtual machines are available in many configurations, including predefined sizes that align to NUMA topology, or as we mentioned prior, the ability to create a custom machine type size for your specific needs. Then you aren't having to manage a single VM. You're also able to use managed instance groups in a way to control an entire fleet of your infrastructure. You're able to define a set of VMs and scale up and down as you need or as your application requires. Now let's dive into what's new with cloud GPUs. Within our cloud GPU portfolio, we have an accelerator for your use cases from ML training and inference, GPU-enabled HPC, CUDA compute, and GPU-accelerated visualization. Our high-end offerings include high-performance GPUs, A100s and B100s that are great for training, inference, HPC, and CUDA compute. On the other end of the spectrum, we have T4s, which are in more global locations, providing you low latency at a very low cost. A very common use case that we see with our customers is training and doing inference on A100s or B100s, and then serving in that global capacity on T4s. Let's take a closer look at our A100 offering. They're available in our Accelerator-Optimized VM Family, A2s on Compute Engine. The A100s have 40 gigabits of memory, and within the VM, you can provision up to 96 Cascade Lake vCPUs and 1.3 terabytes of memory. They're in fixed VM shapes to align with the new transparent NUMA topology, and they can scale up to 16 GPUs for scale up and scale out workloads such as natural language processing and computer vision. But don't worry if you don't need 16, you can go all the way down to 2 GPUs to be able to easily get started. NVLink Fabric is the all-to-all connectivity with up to 9.6 terabytes per second peak bandwidth. You also have access to advanced networking, as well as the option for local SSD. With all these features, you're able to achieve up to 20 petaops of Int8 all within a single VM, which is what I call mega performance. As I mentioned earlier, T4s on Google Cloud are able to provide a low latency at a low cost. They're currently in 18 regions with more along the way. What's new is that we do have flexible T4s in preview currently. You can provision exactly what you need for T4s from vCPU and VM memory. We're also launching automatic CUD renewals, committed use discounts for GPUs. This helps reduce cost and accidental loss of your reservations. Now, here's what's really going to make a difference for you for being able to easily find capacity in your selected region for batch workloads. We have distribution shapes within managed instance groups set to any. The way you're able to take advantage of this is in 3 very simple, easy steps. First, create a managed instance group. Second, set the distribution shape to any. And 3, specify your target audience and region. Optionally, you can also run preemptible GPUs VMs to save money. You can take note of any constraints that you have, such as supported hardware in the zones or resource quotas to get started. We also have the option for deep learning and HPC VMs that allows you to easily get started on our infrastructure within minutes. A simple one-click install and your machine is provisioned and already performance optimized on Google Cloud. It also has compatibility tested, so you have no need to worry about the software stack. Simply select a CPU, GPU, or TPU to add on to the VM. We also provide the choice and flexibility between different ML models, or you have the ability to install your own. 20 Years team was looking for a cloud provider that was just as committed to advancing life sciences and drug discovery as they were. That's why they chose Google Cloud. They also chose Google because we're known for our strength of our network and our security posture. The partnership drastically changed the way they were doing drug discovery. And as Dr. Farid said, this could potentially transform all of the way that pharma is doing drug discovery. As with any large resource-intensive models, costs does start to pile up. The price per performance worked really well for them to create and discover life-saving drugs to help combat COVID. If they're able to do this cost efficiently using custom types of VMs with GPUs, then think about what you'd be able to do with your workload. With the change in consumer behavior due to COVID, Pagani was able to create a virtual showroom to allow you to customize your own car from the comfort of your couch. This virtual showroom is served on NVIDIA T4s with the NVIDIA RTX virtual workstation image. Next, let's pass it up to Omkar to cover cloud TPUs, what's new and what's next. Take it away, Omkar.
Thanks, Chelsea. We have seen tremendous innovation in the field of machine learning in the past few years, and we expect this rate of innovation to grow in the future. However, this fast-paced innovation requires ever-increasing amounts of computing power. As machine learning models get more accurate, they tend to get larger, more complex, and require larger datasets. This is exactly why Google built TPUs, to accelerate the rate of machine learning innovation by delivering high performance ML training and serving at a very low cost. TPUs are used in many products at Google, and it's likely that you have interacted with these when you have used some of Google's products. These accelerators are available to you in Google Cloud right now. Our goal with TPUs is to advance machine learning at Google and across the world. So TPUs are built for this end-to-end user journey of an ML developer or researcher, starting from fast-paced iterative development in the beginning all the way to large-scale production training and serving across a range of machine learning use cases, vision, language, recommendations, and more. It's also easy to get started with cloud TPUs with TensorFlow, PyTorch, or JAX in a Google Cloud project or a collab. You can also bring your own models or use one of our reference models to get started. What's even more interesting is that once you get started with cloud TPUs, it's easy to scale your machine learning models on cloud TPU pods, which means that you can use petaflops of computing power with minimal code changes. This image here shows a cloud TPU v3 pod, which has 2048 cores that are built from the ground up for machine learning. All of these cores are connected together with a custom-built super fast interconnect, which is really what delivers that high performance when you scale your machine learning models on a cloud TPU pod. Combined with the low cost of renting cloud TPUs on Google Cloud, as opposed to owning your own data centers, this high performance machine can unlock completely new opportunities for innovation without any upfront capital investment on your part. To understand the power of easy scalability, just look at our recent results in MLPerf, which is the industry standard benchmark for ML performance. Cloud TPUs demonstrated leading performance numbers across a range of machine learning use cases. And as you can see in the chart here, cloud TPUs can train some of the common machine learning reference models in just a few seconds. For example, DLRM in 38 seconds or BERT in 17 seconds. We believe that this is incredibly valuable, especially since large scale ML training has unblocked some of the recent breakthroughs in AI. For example, Lambda in natural language processing or MUM in multimodal models. Cloud TPUs are particularly well suited for these kinds of compute intensive, large scale machine learning workloads. Over the last few years, we have made relentless progress on TPU hardware and software, and this year we are excited to announce our latest generation Cloud TPU v4. On a chip-to-chip basis, Cloud TPU v4 is more than twice as fast as its previous generation. And at a pod scale, Cloud TPU v4 pods take Google Cloud's machine learning infrastructure to a whole new level with more than 1 exaflop of computing power, equivalent to more than 10 million laptops combined. We have already deployed many of these pods in Google's data centers and will soon have more, many of which will be operating at or near 90% carbon-free energy. Cloud TPU v4 pods will be available to our Google Cloud customers in preview in Q4 2021. Now, it's not just the sheer computing power that pushes machine learning innovation forward. We believe that making the system easy to use is just as important as well. And so we recently launched a completely new software architecture that helps you interact much more easily and much more seamlessly with Cloud TPUs. With Cloud TPU VMs, you can now drive full Cloud TPU pods directly from your desk for the first time. It's like having a machine learning supercomputer under your desk. With Cloud TPU VMs, we aim to make interactive supercomputing attainable to our users. And it's been incredibly encouraging to see positive feedback from our early customers. For example, Hugging Face, which is a leading open source provider of NLP technologies, recently integrated JAX along with TensorFlow and PyTorch in their popular Transformers library. And they were able to pre-train a base-size BERT model in less than a day with just 8 cores of V3, which is the smallest reservable unit of a pod. Similarly, our users at GridSpace, which provides contact center automation tools, such as low latency speech analytics, were able to train both speech and language models with an immediate 2x performance improvement. They were also able to scale these models on Cloud TPU pods with no code changes. These usability and performance benefits make it much easier than ever before to get started with Cloud TPUs and scale your machine learning models on Cloud TPU pods. Along with this powerful user experience, Cloud TPUs also support all the major machine learning frameworks, including TensorFlow, PyTorch, and JAX. We encourage you to check out these links and try out our reference models and tutorials. In summary, at Google Cloud, we believe that cutting-edge machine learning infrastructure should excel at performance, usability, and scalability. So we'll continue to invest in making our systems more easy to use, enterprise class, and open and pervasive. Hopefully, with all of these updates on Cloud GPUs and Cloud TPUs, our cutting-edge machine learning infrastructure is much more accessible and much more useful to you than ever before. Thank you.